Okay, so notes for 5 we're going to work on today and tomorrow on the rational root theorem. And if you'll notice, the objective says we're going to make a list of possible rational solutions. So today it's just making the list. Tomorrow we'll actually be finding the ones that work from the list. So tomorrow we'll be testing our list to see which ones work. And that will have a big connection to what you did on Friday with the sub and what we took notes over on Thursday last week with synthetic. Okay. So here's our rational root theorem, and I'm going to slide these words over. Sorry. The rational root theorem is a list of possible rational solutions for f of x that come from the ratio plus or minus p over q. And I'll tell you what p over q are momentarily. I am going to color code my p's and q's today in the notes. So if you have like colored pens or pencils and you like to also color code your notes, I'm going to make all my p's blue today and all my q's red. Okay, so if you go back into your notes, you'll be able to make connection between the p's and the q's. Rational root theorem creates a list of possible rational solutions for f of x that come from the ratio plus or minus p over q, where p represents factors of your constant and q represents factors of your leading coefficient. So that'll be important. Factors of your constant and factors of your leading coefficient. Remember from our discussions earlier in the chapter, the constant is the term without an x variable. And usually, if our polynomial is written in standard form, where does that show up? The term without an x. It's usually at the very end of the polynomial. Okay, so most of ours will be at the end of the polynomial, our constant terms. Okay, and then the leading coefficient, we'll remember from section 1, is that number that's usually at the very front of the polynomial. It's in front of the term with the highest exponent, and that's your leading coefficient. So all the other coefficients in the polynomial that are like part of the middle terms are not going to matter in making your list of possible rational solutions. You're only concerned, I call them the bookends of the polynomial. The very front and the very end of the polynomial are the two numbers you're concerned with. Okay, now before I go on to the next slide and we do some examples, I want to look at the words possible and rational. Okay, because that's important to this rational root theorem, is that it says you're creating a list of possible rational solutions. Okay, so we want to understand when we say we're making this list, what are we actually finding in the list? Okay. Let's start with the word possible. What does it mean to be possible? It can happen? Does it have to happen? No. Okay, so that's a really good thing that it's important for us to understand. The fact that it's possible means it can happen. It doesn't have to. And when we talk about this list of possible solutions, when we say it can happen, we mean it can be a solution. but doesn't have to be. So this is something that we'll kind of struggle with tomorrow. Okay, we made this list. Some of the numbers on the list could work, but then some of the numbers on the list won't work. So it's not like you're actually making a list of all the solutions. You're making a list of all the possible solutions. Now I just said you're making a list of all the possible solutions, and I misspoke. You're making a list of all the possible rational solutions. So there's some kinds of numbers that you're leaving out. What kinds of numbers are not rational? Irrational, okay? So when we say that it's a list of rational solutions, we are not including irrational solutions, which are possible. An example of an irrational solution could be something like the square root of 2. I mean, the square root of 2 could be a solution to a polynomial. We could plug that in for x and make the polynomial equal 0. But that's not going to show up on our list of possible rational solutions because it's irrational. And so that number gets left off. And there's another set of numbers that until Algebra 2 you didn't know existed. But now you know they're possible, the imaginary numbers. So imaginary numbers are not considered rational either. So this list does not include any irrational solutions or imaginary solutions. If your polynomial has any solutions that fit into one or both of those categories, then you have to have another way of trying to find them. Okay? And we have one way where we can find irrational and imaginary solutions. It's by factoring. Okay? So that's just something to kind of keep in the back of your mind. This list that we're going to create today is not an extensive list of all the actual solutions that there could be for the polynomial. It's only a list of possible solutions that are rational. Okay? And then you're looking at me like, why the heck are we making a list that's not even guaranteed to work and doesn't include all the solutions? It's a place for us to start from. So what we're building into is how can we find all the solutions of a polynomial, if we can't factor it, okay? And then last chapter, in chapter 3, we could always quadratic formula. Now they're not all quadratics. Okay, so we're going to use this list to help us find our solutions. Okay. So we're going to look at some examples of what does this P and Q thing actually mean. So follow along with me. We're going to do the top example right here. F of x equals x squared minus 4x plus 3. Okay, so let's say we couldn't factor this, although if you look at it real quickly, you'll see that you could factor it. We'll talk about that in a little bit. But let's say we were having trouble factoring, and so we needed some other way to find the solutions to the polynomial, and we say, oh, we have this rational root theorem. Let's try that. Okay. For the rational root theorem, we would need to first identify what are our p's and our q's. So our p's are factors of the constant. So I'm going to go to my polynomial. I'm going to find my constant, which is 3. And I'm just going to label it P. What are factors of 3? 3 and 1. So I'm going to write those right below my constant. So I got my P's. Now I need my Q's, factors of my leading coefficient. So I got to go find my leading coefficient. What's my leading coefficient for this polynomial? 1. So I'm going to label that Q. And what are factors of 1? 1. And 1 and 1, and I'll only write it one time because I don't need to have a repeating factor there. So I have 1. And now I want to make that list. Remember on the last slide, we had a list for a ratio of plus or minus P over Q. So I'm going to take one factor from each section at a time to create my list of possible zeros. So to start my list, I'm going to do plus or minus, and I'll start with a P1 and put it over my leading coefficient 1. Well, 1 over 1 is 1. So two possible solutions are positive 1 and negative 1. Other possible solutions, I got to use up all my factors on my constant. So I've got to come here and grab that 3 and take my P over Q again. So 3 over 1 is 3. And I just made a list of possible rational solutions, plus or minus 1 and plus or minus 3. Now tell me, how many possible solutions are in my list? 4. I've got 2 positive and negative 1, and then 2 again positive and negative 3. So I have 4 possible solutions. They could be solutions, but they don't have to be. Jackson told us based on the word possible. And then think back all the way to section 4.1. I gave you that spoiler. How many actual total solutions will there be for this polynomial? What's the total solutions for f of x equals x squared minus 4x plus 3? 2. Damon, how did you know 2 total solutions? What part of the polynomial tells you there are 2 total solutions? Something in the polynomial.
Oh, the exponent is 2.
The exponent, the degree, right? The highest exponent, the degree is equal to the total number of solutions. So of those 4 possible solutions, at most 2 of them could work. Now, tomorrow, we'll actually go through and we'll do the test. We're going to do synthetic, and we're going to be looking for our zeros or our happy faces to know that we found solutions. Okay. Now, some of you can look at this polynomial and you'll say, x squared minus 4x plus 3. I have factors of positive 3 that adds to make negative 4. Negative 1 times negative 3 adds to make negative 4. Negative 1 plus negative 3. So this could factor out as x minus 1, x minus 3, and then the 2 solutions would be positive 1 and positive 3. So note that those 2 solutions that we could find by factoring are solutions in the list of possible rational solutions. So there's connections to be made between your factoring and then this rational root theorem that we're trying out. Okay? Because those are rational, they're part of the list. Okay, let's look at the second one. F of x equals 2x cubed minus 4x squared plus 3x minus 6. I'm going to do the same thing. I got to first find my p's and my q's. Okay, so I'm going to go to the back where my constant is and figure out factors of 6. What are some factors of 6? Just shout them out. 2 and 3. 2 and 3, 1 and 6. Of course, I like to have all my numbers go in order. Do yours have to go in order? No. I just think it's easier to keep track of everything if my numbers go in numerical order. Okay. Notice that the constant was negative 6, but I don't have to worry about plus or minus because in the end, I'm going to put a plus or minus in front of everything. So it takes care of all the sign issues I could have. So you only have to worry about the number. Now I'm going to go grab my q's, which are factors in my leading coefficient. What's factors in my leading coefficient? 1 and 2. So this means I have extra work. Now I have to take all my p's, 1, 2, 3, 6, and put them over the first factor of my leading coefficient, which is 1. So 1 over 1, 2 over 1, 3 over 1, 6 over 1, and they're all just going to be themselves, right? So when I make my list of possible solutions, I'm going to say plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. That's taking each of these p's, 1, 2, 3, 6, and putting them over 1. Something over 1 is just itself. Now I gotta go back and take all those p's, all those factors in my constant, 1, 2, 3, 6, and put them over 2. So I gotta repeat the process. I'm gonna take 1, 2, 3, 6, and put them over 2. I only have to write new factors. Okay. So 1 over 2, is that new?
No.
You don't have a 1 over 2? Or you do have a 1 over 2? I don't see a 1 over 2 anywhere. That's 1/2, isn't it? I think 1 over 2 is new. Do you have a 2 over 2? Yeah, because 2 over 2 reduces to be 1, and 1 is already on the list. So I don't have to add a 2 over 2. Do I have to add a 3 over 2?
Yes.
Yes, that's new. I do not have a 3 over 2. Do I have to add a 6 over 2? No, because 6 over 2 is 3 over 1, which is 3, and that's already on the list. So now I have this list of possible rational solutions. How many possible solutions are there in that list? 6 positive. So 12 possible solutions, because you have 6 positive and 6 negative possible solutions. And then how many will you actually have for total solutions of your polynomial? Only 3 total solutions. Okay. So you can see leading up to tomorrow, a problem like our first one wouldn't be so terrible just to do like some guess and check. I have 4 possible and 2 of them are going to work, so half and half. Okay. Here, I could end up doing a lot more work. I have 12 possible, only 3 of them are going to work. It's going to be harder to find the one that works. Okay. So we're going to be working with that concept tomorrow. Does anybody have any questions on those top 2 right now? Okay, I am going to have you work on 2, and then we'll go over them in a little bit, and then I'll give you your homework assignment to work on. So for right now, I would like you to work on f of x equals x to the 4th minus 3x cubed plus 6x squared minus 2x minus 12. Make just the list of possible solutions. And then when you're done with that one, the more challenging one, f of x equals 8x cubed minus 6x squared minus 23x plus 6. Be very careful with your list of p's and q's on the second one. Okay, so just really quickly, I thought you guys did an excellent job on the first one. It's always easy when your leading coefficient is 1, right? Your list is just basically the list of p's because you put them over 1. So plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. And you should have 12 total, 6 positive, 6 negative. Of those 12, 4 will work, possibly. Okay. And then for the bottom one, I walked around. I think I checked most people's P's and Q's, which I agree with. And then the important thing here is when making the list, just be very organized and make sure that you're always following the rule of P over Q. Take the blue numbers in the back and put them on top of the red numbers in the front. You can't go in the opposite order. So you should have found 20 total possible solutions. So we'll start with our list of P's by taking all of 1, 2, 3, 6 and putting it over 1, and then we'll go through and create the fraction possible solutions by taking 1, 2, 3, 6 and putting it over 2. You'll only get 2 new solutions, 1/2 and 3/2. Okay. 2/2 will be 1 and 6/2 will be 3, which are already on the list. Then I'll take all 4 of the P's, 1, 2, 3, 6, and I'll put them over 4. Again, I'll get 2 new solutions, 1/4 and 3/4. 2/4 will reduce to be 1/2, and 6/4 will reduce to be 3/2, so they'll already be on the list. And then I take all of my blue factors, 1, 2, 3, 6, put them over 8, and I'll get 2 new factors, plus or minus 1/8, and plus or minus 3/8. 4/8 will be 1/2, and 6/8 will be 3/4, which is already on the list. So we have 20 possible solutions, of which only 3 might actually work. Okay, and then you're not even guaranteed that. Okay, so maybe only one of them works. Okay, so your homework assignment for this evening is page 194, and the directions will tell you to solve and like figure out what the zeros actually are. I'm not going to ask you to do that until tomorrow. So tonight, I really just want you to make the list like you did in class today. Forward